you. First, I'd like to welcome everybody and say good morning, good afternoon, good evening, whatever time it might be within the location you're joining us from. As Renan said, my name is Jeff Bonkoski. I've been with Hazard Control Technologies now since about 2012. In some way, shape, or form. Originally, I was a career firefighter. Throughout my career as a firefighter, I trained and learned as much as I could about hazmat response, hazardous materials, training to the level of a hazmat specialist. I was a paramedic, and I even went on to become a tox medic, so I could deal with WMD agents and things like that. So I pretty much used my career in the fire service to learn as much as I could about hazmat and some of the high hazard fires that firefighters might face. And after retiring, I was hoping to make it my goal to make our firefighting profession a safer profession. And I started out with the ethanol industry doing consulting work, and in dealing with those types of fires, it led me to hazard control technologies and the things that I've learned, and even hazard control technologies goals are pretty much the same in trying to make firefighting a safer profession. And it's one of the things that's becoming I guess you could say, a little bit more common hazard. We hear about them in the news and the media constantly, about the hazards of lithium-ion batteries. And so I'm hoping to give you some insight and some of the things on, because so many times we hear it's water is the only answer. And you know what, that's not the case. There is some technology, and I hope to share with you encapsulator agent and the abilities encapsulator agents bring. So when we sit there and we start looking at lithium-ion batteries and the construction of them, again, it's just, the positive, negative electrodes going back and forth, discharging, recharging. And the popularity of the lithium-ion batteries, if we remember, years ago when we had the nickel metal hydrides and some of these other types of batteries, they would develop memory. They would charge so many times, and then they would kind of stop charging to their full potential. And when we would use them, they would gradually, slowly lose their energy, and your tools or whatever it might be might not work as efficient. But with the development of lithium-ion batteries, we had a very reliable energy source that offered us almost the full power of the battery for our tools or whatever it was used in, almost until it was out of energy, and then it was a rapid decrease. So they've been a very, very efficient source of energy for us. And when we sit there and we start looking at, concerns, demand, yes, it's growing and it continues to grow. I'm trying to develop new batteries that are able to even store more energy and especially in automobiles or other things, be able to get longer distances per charge. So the demand for these types of batteries is great. And we look at, our diversity, all the materials that are needed into developing, making, and putting these batteries into our devices. We deal with multiple classes of fires. Not only do we do that, but what many people don't take into account is the toxicity of the batteries, especially when they're burning, with the electrolytes and the gases that are being released as far as the flammable gases or the gases that are being released. And we'll talk about those. And then again, the shock potential because of the strong density of those types of batteries. So when we sit there, we start again going back to that diversity, and we look at all the different types of materials that are used in the makeup. We've got plastics, we got the flammable electrolytes, we got that energy, that class C shock potential. So while the batteries may be classified as one category, maybe a class A, as you can see, there's many different classes of fires that they can fall into. And now, when we sit there and we start to talk about, again, those news articles that we see on the news or we read in magazines, that battery failure, well, what causes it? And you know what, it could be something when the battery was made, there could have been some impurities, or could have been some things that may have been overlooked when they were building these batteries, and the batteries can become unstable and short circuit. Trauma, auto accidents with vehicles, dropping our phones or dropping the batteries for our power tools, the overcharging. Yes, we, in most cases, have devices that are built into the batteries to help prevent that. But again, as we know, sometimes these devices can fail and we can end up with an overcharge situation. And then we have the issues with overheating. And I'm sure many of us, cell phones are a great example. You're outdoors having a drink, set your phone on a table on a sunny day. It's not in the shade, sun's beating down on it. You go to pick it up and your phone's extremely hot, or, you leave it in your car, same thing. And, you have that, cool down mode before you can reuse it because it's gotten so hot. And one of the things I like to talk about, because when I do many of these presentations, especially when I sit there and I start going into some of our larger cities here within the states, many times I hear the saying that, hey, we have fire hydrants, we've got, trucks, we got all the water we need, water's free. We don't have any issues with water. Unfortunately, that's not the case everywhere. And when we sit there, we start going back and we start looking, let me go back to this one. When we start going back and we start looking at, places out west or other parts of the world, we've got problems with the drought. We don't have water that's basically free.
To the deadly crash involving one of Tesla's
and here's a good video.
Autopilot feature. The car slammed into a tree and burst into flames. Police tell ABC News it appears no one was in the driver's seat. Here's ABC's Gio Benitez.
Tonight, mystery surrounding a deadly crash near Houston involving a Tesla Model S. The charred wreckage captured on camera after it crashed into a tree and burst into flames. 2 men inside were killed. The Tesla's high-energy battery reigniting over and over again. Firefighters trying to put the fire out for 4 hours with more than 30,000 gallons of water. The fire eventually put itself out.
Okay, so here we go. How many places, especially in those areas where they have drought conditions, can afford to use 30,000 gallons of water on one car fire? Okay, they've said multiple reignitions. They were able to extinguish it. It reignited water. And when we hear copious amounts of water, well, you've just saw 30,000 gallons of water and they didn't put it out. It burned itself out. So what is your definition of a copious amount of water? When we start hearing people talk about, oh, we just need a copious amount of water. So when we sit there, we start going through and we start looking, the lithium-ion batteries are growing in use, in our warehouses, our cars, no matter where we're looking, our laptops, our computers, our power tools, not only at home, but in the fire service and in the, in different industries. We got vaping, the dangers and the hazards of these batteries are growing daily. And I hear many times people say, well, the answer is let them burn. What happens if that car is in a parking structure? What happens if that is in a building? What happens if that's in a warehouse or a manufacturing facility? Are we going to let it burn? Is that the way we're going to sit there and decide that we should handle these types of fires? So the question becomes, are we prepared? And hopefully, as I talk a little bit more about our encapsulator agent, we sit there and we learn how that agent works and how it's able to stop thermal runaway and cool. You'll go away with a better understanding of how we can safely deal with these types of hazards. So as we keep seeing the popularity of these lithium ions grow on a daily basis, and we keep finding all the different uses for them. We're finding them in all of our consumer goods and all of our things, automotive industry. Okay, yes, we got electric and hybrid vehicles, but how about all those charging stations that are now starting to pop up again in parking garages? Okay, And how about dealerships? How about when we sit there and we start looking at body shops, how about welding robots and some of the other things, repair facilities? All of these areas are places where we can find possibly batteries that have been, especially with towing companies and some of the other things, subject to trauma. When I sit there and I show this picture, again, these are just some of the things that as I've been driving around the country and the United States, I see these charging stations that are, being erected or put up in parking lots. And one of the things I don't really see are disconnects. I don't see ways to really, if something were to happen. How about, inside of a parking garage, at an airport or some other facility? You're putting these charging stations in, but I don't see any additional fire extinguishing taking place. But yet we sit there and we say copious amounts of water. How is a fire department supposed to, in a structure that's got a, maybe a 7-foot height requirement, supposed to get a truck that's 8 feet, 9 feet tall in to get copious amounts of water in? We start seeing our problems. But not only that, but on our service trucks, on utility trucks, on our fire apparatus, we have many of these batteries. And you figure, let's think about this with firefighters. How careful and how easy are we on our equipment sometimes, in the heat of the moment when we're trying to extricate a person, when we're trying to do some work? Those batteries can get abused pretty good. When we sit there and start looking and talking about, our aviation, we start looking at some of our loading devices or ground handling equipment. Again, at those parking garages, we have our forklifts, battery backup systems, radars, battery backup systems for the radar, and then all the consumer electronics. How many people go through the airport or around the airport that have lithium-ion batteries? Again, with our industry, warehouses and places that are trying to, have a cleaner atmosphere, their industry is getting away from the propane or the LP powered high-lows, and they're looking at lithium ion, keep that air within the facilities cleaner, make things safer, hopefully environmentally for the employees. And then in our cities, we're trying with transportation, again, looking for ways that we can reduce our emissions and make the air more breathable, especially with people that might have some of our chronic breathing issues. So we sit there, we start looking at these electric buses and things like that. But I want to point out one thing when we sit there and start doing it. I'll let the volume play a little bit. You can hear it. Okay, let me go back to that. I'm sorry, I didn't mean to go forward so quickly. But one of the things I wanted to point out, I'm going to turn the volume off at this point, is because once that vehicle started to catch fire, now let's think back to that previous video with all the buses, the transportation buses. We have the same situation that could occur here. Look at how close these vehicles are parked to each other. The one vehicle catches on fire. Now it catches the truck that was next to it on fire, and the brakes fail on the truck. The truck rolls back, but still, even though it's rolled back and it may be affecting things that are out of our vision, look at the car that's off to the side of it that is just starting to get a little char on the back bumper. I'm going to speed it up a little bit. Now we sit there, we start to see some flame impingement. We start to see it catching on fire. So even though that truck is kind of rolled away, that radiant heat, the heat that's being generated from those batteries and from that truck burning are catching the vehicle next to it. And it's going to continue to grow and to continue to be an issue. And again, one Tesla, 30,000 gallons of water. How many gallons of water are we going to need for multiple vehicles when we sit there and start looking at the threat? Okay, how about transportation? We have a tractor trailer. Lithium-ion batteries going down the highway. Maybe cause fire and put something in the paper and start getting batteries going. How much water? We sit there and start looking at airport. As I said, some of our airports are starting to use these ground equipment, and they're again getting away from fuels and going into lithium-ion battery powered. The issue becomes you don't have the right type of agent to deal with these types of hazards. Okay, so now we have maybe a $30,000-$40,000 support vehicle destroying or basically taking a multi-million-dollar aircraft out of service because we don't have the right type of extinguishing agent. You can see those batteries bursting underneath it as it goes. So we sit there and we go on and we start looking now at consumer electronics, our cell phones, our laptops, our gaming consoles for our kids and things like let them have some fun, our power tools, hoverboards. And a few years ago when hoverboards were just starting to be released and they were a big Christmas thing, how many fires did we have in the US or around the world where hoverboards were involved? And now within the cities, we're starting to see these scooters and these e-bikes start to become a way of travel, way to get around the city. Rent a scooter and make your way around the city a little easier. And then our remote controlled toys, and again, battery backups for our homes. And these batteries, when we sit there and start looking at lithium-ion batteries, they come in multiple sizes, shapes, especially when we sit there and start looking at some of the ones just for our power tools. I mean, you can have one battery that's maybe a 20-volt battery, but based on amp hours, the size of the battery could be, twice as big for the same tool. You could have one that's, maybe a 2 amp hour versus one that's 6 amp hours. And, it makes that battery bigger, holds more power, holds more energy. And then we're sitting there, we look at these multi-chargers. So now we're taking multiple batteries and we're putting them in. When we look at our tools, especially when we, again, get into the fire service and our extrication tools, we're putting them through, again, some abuse, rapid discharge, then putting them back on an apparatus and charging them up. So they could be hazards. Here's a scooter. Again, we take, sounds like everything's okay, a little smoke. But just how quickly, how violently that battery in that scooter reacts. Look at the smoke. Look at the cloud. Okay, here's again, a laptop on a chair plugged in. Not just how violently they can sit there and they can go when they're in the overcharge or they start getting into the thermal runaway. The hazards that they bring. You have an e-scooter. Like use some water. They've used some water. They've looked like they might have even probably used some powder. However, they're not able to stop that thermal runaway, which is what we need to do in order to extinguish the batteries. And again, I'm going to go back to that Tesla. 4 hours. They couldn't put the fire out because it kept reigniting because they were using water. Water does not stop thermal runaway. So when we sit there, we start looking at energy storage systems, residential, we look at Tesla, going too fast here. We look at Tesla wanting to put battery walls in residential homes. Okay, look at industry trying to figure out ways that they can reduce their power usage. And then mass energy storage systems that even the power companies are starting to go to, battery energy storage systems where they do power shaving. They use these huge batteries to basically store energy during the non-peak hours, and then during the high demand uses when people are trying to air condition their homes in the summer and on a hot day, or trying to do things, they're able to then release that energy that they store in these batteries to the grid to power homes and wherever it's needed. And just example of some of these, they're huge. Some of them are, like say, Connex boxes or multiple Connex boxes, but we're hearing and we see where some of these batteries and some of these systems fail. And again, the problem becomes many of us in the fire service don't know or don't have a clue on how to deal with them. And the only thing, and people tell them, is copious amounts of water. And just to throw a few isolated examples out, here, January 19th, the plane evacuated because of a mobile battery. We had a boat, Muelsdorf battery, 5 people were injured, a power bank, and an Airbus, I had plane again evacuated. How about April of 2019, where one of those battery energy storage systems failed, causing an explosion that caused injuries to firefighters. Some of them were career ending, that ended their career. We have, fires with an e-bike, 90 people evacuated, 9 in hospital with toxic gas poisoning. And again, we'll talk about some of those and so on. So we read about these and we see these in the news constantly. We sit there and start looking at the medical industry, pacemakers, glucose monitors, surgical cameras, our infusion pumps, the uses again of the lithium-ion batteries just goes on and on and on. And we keep trying to, it appears, to find additional sources and uses for them. Even in the mining industry, again, in the mine and closed areas, they've got enough problems with, different types of gases, methane, hydrogen sulfide, and things like that. So rather than having vehicles that use some type of a petroleum product to get the cars out of the mines, how about using electricity? Now I'm going to go back to that video that we saw here just a little bit when we got a glimpse of it. Here we have our warehouse. We have our high-low. The high-low doesn't appear to have been abused in any way, but batteries failed. Yes, the forklift driver was able to get off, but here we have a high-low sitting there. And when we sit there and we start looking at fire codes in different types of occupancies or different types of buildings, what's the common extinguisher that is required? And it's an ABC. So the employees right now, as you see, they're starting to run around. Here comes one right now. He's got his dry powder ABC extinguisher, and he's starting to make an attack on the fire. We get a few more that start coming in that are trying to extinguish this fire. And if you sit there and if you start counting, I think at one point in time, I believe I've counted about 8, 9 extinguishers, and it appears that they're having a pretty good effect on being able to extinguish this difficult fire. However, powders do nothing to cool a battery. And, well, we forgot. In the heat of the moment, the driver didn't put any type of brakes on the high-low, so now the high-low goes rolling into the facility, and we lose a $250 million warehouse and many jobs because, it burned up. And here again, we have a bus at a depot. Bus catches on fire, it's now not only the bus that's going to be burning up, but you can lose multi-million-dollar buildings. So I throw the question again out there. Are you prepared? And I'm hoping that as I go through here, I can help answer that question. Well, again, the video that was just shown, the dry powders, we saw how ineffective they are. They don't do anything to remove the heat. We had that reignition. Okay, it doesn't do anything to reduce the toxins of the smoke that's being released by the batteries, or does it do anything to reduce the flammability of the electrolytes that are within the battery? So it's really not a good choice. And here's a quick video showing powders. We have 182 batteries. They're the 18650s. They're 95% charged. Okay. So here we have, the dry powder being used. And as you can see, it's absolutely totally ineffective on being able to extinguish this fire. Just look at all the gases that are being emitted as these batteries are burning and how violently that electrolyte is going. So the next question is in our firefighting toolbox, we have foam. Okay, well, if water doesn't work, let's foam it. But foam doesn't do anything to remove the heat as well. What do we do when we're cold? Okay, if you're cold at night, you pull up a blanket. What does foam create? Foam creates a blanket. It causes a separation between the fuel and the oxygen. So what do you think? It's not doing anything to remove the heat. Okay, it doesn't do anything to stop that reignition. Not only that, but it doesn't do anything to reduce the hazards from the toxins or the electrolytes. So it, again, is not an effective extinguishing agent. And again, same number of batteries, same voltage. Okay, and now we're going to sit there and we're going to do a test and we're going to try some foam. Foam isn't very effective. It's really not doing anything. I don't really see that fire dying down very quickly. I mean, and pay attention, he's using a constant spray. Okay, he's using a constant spray, trying to extinguish those batteries, and he's having no luck at being able to do it. Inerting gases. A lot of people are, have, and I'm going to say when we sit there and we start looking at those battery energy storage systems, those Connex boxes or those buildings, the structures, the inerting gases seem to be the way a lot of people are tending to because they figured, hey, we can smother the fire. But again, it doesn't do anything to remove that heat. Okay, so once we start getting some air, oxygen back into that room, we're going to have a reignition because those inerting gases do not do anything to cool. It does nothing to reduce the toxins in the soot, the smoke, or in the electrolytes. So inerting gases are, again, falling into that ineffective category of agents. And here's a different video that shows the use of an inerting gas. And luckily, the engineers that were working on this robot at the time were able to, or had taken a break, and they were away from the robot when it had failed. But, here we have basically a CO2 inerting gas type extinguisher. Yeah, it comes out icy cold, but it's not having much of an effect at being able to cool and extinguish these types of batteries. Again, when we look at, another one comes in, we continue to try, but look at all the toxic acid coming out off of this battery. While the flames may seem to be out, that battery will reignite because we have not been able to eliminate that heat from the batteries. Water. I've mentioned it many times through this presentation so far, and I go back to the Houston Tesla, 30,000 gallons. copious amounts of water. What's the definition? How much is a copious amount? Well, we see in Houston, one Tesla in 30,000 gallons didn't meet that criteria because the vehicle ended up burning itself out. It kept with the reignition. They said multiple times they'd get the fire out with water, it would reignite. So again, they were unable to stop that thermal runaway. But with 30,000 gallons of water, what do you think all the toxins, where do you think all those toxins went? You know, we washed them right down the sewer, we put them into the environment. You know, we basically could have created a huge mess environmentally. So is, again, a copious amount of water a practical solution to dealing with these types of batteries? Or, again, when I mentioned, let it burn. Okay, here's the video again. I'm not going to go ahead and play it, but it just shows you how ineffective these types of solutions are. So let me start discussing and educating and talking about encapsulator technology. We've seen how all these other agents are somewhat ineffective. We know about our current foams, the hazards that they bring with the PFOS or the PFOAs, the forever chemicals, the fluorinated ingredients. When we start looking at an encapsulator agent, F500, it's 100% fluorine free. It's non-corrosive and it's biodegradable. Not only that, but it's a CULS and NFPA classified AB fire suppression agent. Thing that I like to point out as well, combustible, flammable vapor and liquid spill control. Can you tell me, does foam or water that we currently use in the fire service control vapors? Okay, something to think about. Here we have an agent now that works to deal with some of the hazardous
encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
Okay, I wanted to let that play so that you could get a better understanding of it and understand what all the categories of agent we've talked about up to this point. You know, we've talked about that dry chemical and things like that. When we talk about foam, what are we talking about? We're talking about an agent that creates thin wall bubble structures that causes that separation. Well, you just saw in that last video, when we sit there and we start introducing an encapsulator agent F500 into the water stream, we are chemically changing the makeup of the water droplet. And in changing that chemical makeup, we're changing how that water droplet is now able to cool, how it's able to extinguish. And when we go back, we sit there and we look at, you know, the cutout of these micelles. Okay, yes, when it first comes out, we sit there and the ones closest to the surface, they spin out and they put that skin on the surface. And we talk about all of those spherical micelles that are still inside of each and every droplet. And there's millions and millions of them. To give you an idea, if we were to use the size of the Earth as the size of a water droplet, the micelles that are inside would be the size of a BB. So give you some idea of just how many of these spherical micelles are inside of a water droplet. And they change, again, how that water droplet is able to cool and extinguish. And one of the things that it is able to do, it's able to cool without the creation of steam. Okay, we're able to take temperatures that are in excess of 1,300 degrees and drop them down to 120 degrees in seconds with no steam. Again, huge. How many times in the fire service have we had firefighters that have come out with steam burns because of using plain water? Let's now take and talk about the encapsulation. Okay, what does it do? Well, when we sit there and start looking at what an encapsulator does, we're going to start with the lithium-ion batteries. We're going to key in on the flammable electrolytes and how an encapsulator agent is able to render that electrolyte non-flammable. We're able to reduce and eliminate the flammability of that electrolyte. Mentioned that rapid reduction in heat. So we've got independent testing that shows, that, the ability to rapidly cool and stop that thermal runaway is key to being able to stop these batteries. And here's the battery that was used in testing where F500 was used. And as you can see, all the batteries to the right, they've started to fail. They've gone in and we have thermal runaway taking place. But when we start getting to the left, F500 was used to extinguish the battery. And all of the batteries to the left are possibly and could still have somewhat of a charge to them. But the F500 was able to extinguish the ones that had been affected and were in thermal runaway, was able to cool and able to stop and extinguish this battery. Let's talk about the toxin. What is the gas that's being released when these battery burns? And it's hydrogen fluoride. Hydrogen fluoride gas is involved. So when we sit there and we start looking at these batteries emitting these gases, we had, I shouldn't say we had, but in some of the testing that was done, there was a gentleman that was using those extinguishers. When we saw those previous videos of the batteries that were burning with the dry chemical and with the foam, the gentleman that was extinguishing those batteries wasn't wearing air pack. He wasn't wearing breathing apparatus. And he spent some time in the hospital detoxing because of his exposure to hydrogen fluoride gas. So it is a toxic gas. But when we sit there and we start also knocking it down with water, we could be turning it into an acid, as well as mixing up with the electrolytes. So let's again start talking about the effectiveness of F500 on lithium-ion batteries. While we've talked about being able to stop that thermal runaway, we've talked about the ability of an encapsulator agent F500 to rapidly reduce temperatures and stopping thermal runaway. We're able to, and mentioned the ability to encapsulate those electrolytes, stopping and preventing a reignition. We inhibit the toxics, the gases that are being released. So it's a highly efficient product to be used when we sit there and start looking at lithium-ion batteries. And we sit there and start looking at some comparative testing. Okay, this is a good video. You will see that gentleman to play side by side, all three of the agents we've talked about. When we sit there, we start watching the gentleman come in, you notice he's not using a constant spray. He's just using short little spurts, short little blasts. Look at the effectiveness that an encapsulator agent F500 has on being able to extinguish that battery. But as you can see here, as he comes in on the powder, he doesn't have an air pack on it. Look at the gases and the toxins that are being released in the batteries as they burn. These tests were done by Kiwa Labs on behalf of HCT Europe and Johnson Controls in trying to find a solution, independent third-party solution for one of their clients. And they had asked F500 to participate in the testing, and we agreed as long as they shared the results. So this is why you see Johnson Controls name on this particular slide, is because this comes right out of their literature where they're showing based on the tests that they did over the course of days, that powders were poor, not recommended, do not apply. Look at foam. Well, Johnson Control's a major foam manufacturer, so they really don't want to bash themselves too much. So they give it a moderate to poor, but in the remarks, not recommended to apply on a lithium-ion battery. Let's look at F500 encapsulator agent. They give that a sufficient all the way across the board. And they do make the recommendation, apply on lithium-ion battery fires, because in their testing, they were able to show that they could stop thermal runaway in lithium-ion batteries. And right now, as you can see in the conclusion for Johnson Controls, it's able to stop the lithium-ion. It's has a direct impact on being able to cool, unlike foams, and it's able to suppress those vapors, and encapsulate the electrolytes that would be part of an ongoing hazard. We sit there, we start looking at polymer pouch style batteries. These might find in computers, they might be laptops or tablets. But when we sit there and we start looking at that encapsulator agent being applied, I'm going to back it up here 1 second. Okay, on this particular slide, when the battery does fail, even though we're not getting encapsulator agent directly into the pouch, we're cooling the outside of that pouch. Okay, we're able to cool it, even though we're not getting inside of the pouch. We're able to cool that battery enough to where we're able to extinguish that without getting inside of the battery. When we sit there and we look at this one from a different angle, different type of battery, again, it's a polymer pouch. The battery's coming out of the plastic housing. And when this one burns, again, it's going to show it's not a direct contact with the extinguishing agent. The extinguishing this is off of that plastic frame, and it's extinguished without direct contact, just that overspray. That's how effective the encapsulator agent is at being able to extinguish and deal with these types of hazards, these types of fires. Another one, this is a one where we're getting into the 18650s. This is a rather long video, so I'm going to kind of speed through it here a little bit. As we go through, we have thermal imaging. We have our temperature sensors that we have on the bottom right. We get a lot of good information on this video. As I said, I'm going to kind of speed through it here a little bit. We sit there and we can see our temperature starting to rise a little bit on our cells. Okay, we sit there and we see, now we get into that thermal runaway. I'll back it up just a little bit so you can see that heavy smoke that starts to build. And once we start seeing that heavy smoke, like we've seen in the videos with the car being charged and all the other batteries that we've seen, we see that little puff of smoke just before those batteries fail. So you're going to see the top left video there. It's going to start, and then all of a sudden we get into our one battery that may have failed. That one battery has enough energy and enough violent reaction in it where it causes enough heat to cause the battery next to it to go. And as we go through and we sit there and we continue to see the fire grow, we'll watch our temperature sensors on the bottom here. Okay, we'll sit there and we start watching them. The one I like to watch is our number 5, I believe it is. You're going to sit there and you're going to start seeing how these temperatures. And the reason why I want you to pay attention to those temperature sensors is I mentioned that rapid ability to cool. Okay. And when we sit there and we start looking at these, look at kernel 5, getting up to 600 degrees, it continues to climb up. We're starting 600. Okay. When we sit there and we have the agent discharge, the F500 right now, watch that temperature went from 600 down to 3, down now it's 17. How quickly we've stopped that thermal runaway. And we can sit there and we can go on, like say the video continues on as we go through, and as you can see, you know, the amount of steam coming off the battery is continually decreasing in our temperatures. Okay, they're not climbing, they're not going back up. Okay, they're remaining down low. We have stopped thermal runaway. This battery has been extinguished. So when we look at our solutions, I mean, HCT and the products, we're able to help out in many different areas as far as educating employees, you know, the fire departments within your jurisdiction. If you're a company, if you're, you know, a person within a community and you need education on these types of batteries, by all means, we can help. We can, as far as training in equipment, sharing reports, but encapsulated technology has been tested for many, many years and has proven to be very successful. And when we sit there and start looking at some of those warehouse applications where, you know, those ABCs may not have been the answer, the solution, we have what we call our quick attack mobile units, as well as 2.5 gallon or 6 liter extinguishers, the carts, and what we call our CCS systems, our sprinkler systems. That, you know, if you have a sprinkler system within your facility that you would like to add additional protection with, we can help in that area as well. Then we have some of our different compressed air systems. So with that one, but some of the areas when we sit there, we start talking about the concentrate control systems. The concentrate control systems would be these tanks. You probably have them, are risers. So one of these tanks could actually protect multiple areas, especially if they're charging areas. You have, you know, or a parking structure and you have multiple floors where you need protection for charging stations for cars. The one to the right is a water-driven proportioner, which is, again, a very good system. So we can help out with all the different areas that you may be looking for protection. We work with your fire protection contractor, your fire protection engineering company, to help to make sure that, you know, we get the system customized to fit your needs. So, you know, the question becomes, you know, are you ready to help encapsulate the world? You know, all of these companies are, and I point out, when you sit there and you see the names of these companies and you sit there and you start getting into the news and you start getting into the different magazines where you hear about batteries, have you ever heard a person that's written an article or a news person ask, what do these manufacturers of the batteries use to protect their facilities? And here you have it right here. You know, these are companies that we are working with right now to protect their facilities in the event they have a lithium-ion battery. And this one was shared with me by Hernan. Here's a fire truck, a lithium-ion battery fire truck. Pretty impressive when it works, but it's also impressive when it doesn't. Look at all the smoke. Look at the violence. How violently those batteries. Now, what happens if there's somebody close by when that were to fail, that explosion? So it's like, you know, hey, I want to thank you all for being part of our presentation tonight, for taking time out of your day. But I have to get into, you know, hey, it's time to wake up. It's time to sit there and look, instead of asking the questions of what is there or how do we react to these types of emergencies. The solution is here. It's now getting the message out and the training out to people like you who have attended tonight, so that we can sit there and we can make places where these batteries are used, made, stored, warehoused safer. So I want to again thank you. I hope my presentation was able to enlighten you and give you some ideas and some ways to protect your communities and yourselves.